Understanding war driving. Hackers use war driving as a method of identifying vulnerable wireless networks. The intruder drives around with inexpensive hardware and software that enables them to detect unsecured access points. War driving is not illegal, but using a business network's resources is illegal. War flying involves using an airplane wired with an antenna to identify those same vulnerable Wi-Fi networks. How war driving works. War driving works when an attacker or security tester drives around with the following equipment: a laptop computer configured to detect wireless networks, a wireless network interface card. Not all are compatible with scanning programs, though. An antenna capable of detecting radio waves. Prices vary on the quality and the range. And software that identifies the following: the SSID, the security type that is enabled, and the appropriate signal strength. NetStumbler. NetStumbler is a shareware tool written for Windows environments. Enables WLAN detection and supports 802.11a, 802.11b, and 802.11g standards. NetStumbler is primarily designed to verify a WLAN configuration, detect other wireless networks, detect unauthorized access points, interface with a GPS, and enables mapping of all detected wireless LAN locations. NetStumbler continued. NetStumbler also logs the following information: the SSID, the MAC address of the access point, the manufacturer of the access point, the channel on which it was heard, your signal strength, and the encryption method in use. Attackers can detect APs within a 300-foot radius. With better antennas, they can even locate APs a couple of miles away. Kismet. Kismet is a product for conducting war driving attacks. It was written by Mike Kershaw and runs on Linux, BSD, Mac OS X, and Linux PDAs. Kismet is also a sniffer and an intrusion detection system, or IDS. It can sniff 802.11b, 802.11a, and 802.11g traffic. Kismet continued. Some of the features of Kismet are: it does Wireshark and TCP dump compatible data logging. It is compatible with AirSnoot and AirCrack. It can perform network IP range and hidden network SSID detection. It can do graphical mapping of networks. It can reveal client-server architecture. It can report the manufacturer and model identification. And it can detect known default AP configurations. Kismet produces its output data in XML format and can support more than 25 different card types. Understanding wireless hacking. Hacking a wireless network is not much different from hacking a wired local area network. A hacker uses the same basic techniques: port scanning, looking at every port on the computer to identify open doors, vulnerabilities, and such, and enumeration, identifying unprotected user access and network devices. Tools of the trade. Some of the tools used by hackers for their work are a basic laptop computer, a wireless network interface card, an antenna capable of receiving radio waves, different software sniffers, and wireless routers that perform dynamic host configuration protocol or DHCP functionality, which poses one of the biggest security risks. Some of the hacker tools for cracking web keys are AirCrackNG, which can recover keys once enough data packets have been captured, and WebCrack, which is an open source tool for breaking web secret keys. AirCrackNG. AirCrackNG is a tool used by most hackers who want to access web-enabled WLANs. It replaced AirSnort. AirCrackNG provides one very useful addition, which is the Jerix Wi-Fi cracker with a very facilitative GUI front end. Countermeasures for wireless attacks. Some countermeasures for wireless attacks would be to consider using anti-war driving software. This would make it more difficult to discover your wireless LAN. You could also set up honeypots to lure attackers to a false, albeit real seeming environment. In addition, the Black Alchemy, fake AP, could be used to generate counterfeit 802.11b access points and hand out bogus SSIDs. This organization could also use measures for preventing radio waves from leaving or entering the building, such as using special paint on the walls, or using a router that filters unauthorized MAC and IP addresses and prevents access. Countermeasures for wireless attacks continued. The organization should also consider using an authentication server as a countermeasure against wireless attacks instead of relying on a wireless device. Consider using EAP to provide a layer of authentication, security, as it allows different protocols that better enhance security. Place all access points in the demilitarized zone, or the DMZ, and use a firewall to filter out traffic. If possible, upgrade the WPA2 and replace all hardware that can't be upgraded in order to protect for better security. Countermeasures for wireless attacks continued. Finally, as another countermeasure, assign static IP addresses to wireless clients instead of using much more vulnerable DHCP functionality. Change default SSIDs and disable SSID broadcasts. If you can't disable the SSID broadcasts, at least rename the default SSIDs to something else. The summary. Wireless technology defines how and at what frequency data travels over radio frequency spectrum. Some of the basic components of wireless networks are WNICs, access points, wireless networking protocols, and SSIDs, which are configured on APs to use to identify WLANs. Summary continued. IEEE's main purpose is to create standards for LANs and WANs. 802.11 is the IEEE standard for wireless networking. The Basic Service Set, or BSS, is the collection of all devices that make up a WLAN. BSA is wireless coverage area the AP provides. The primary WLAN technologies are infrared, narrowband, and spread spectrum. Summary continued. Bluetooth is the most popular form of wireless PAN technology. WEP, WPA, and WPA2 are wireless encryption standards to protect wireless LANs. Authentication usually is used in combination with wireless encryption standards. War driving and war flying involve driving or flying with a laptop, wireless NIC, an antenna, and software for available and potentially vulnerable APs. Summary continued. WLANs can be attacked with many tools used for hacking wired LANs. Some countermeasures or deterrents to these hacking attacks can be to disable the SSID broadcast and rename default SSIDs. Using an authentication server and placing the AP in the DMZ are also effective countermeasures. Finally, using EAP and a router, upgrading to WPA2, and assigning static IP addresses to wireless clients can help deter hacker attempts against the wireless network. This concludes the Week 7 presentation.